All right, everyone, let's go ahead and do this. If you haven't had a chance yet, homework number 2 is already up. This is homework number 3. Part of the vocabulary to describe each type of account as a simple interest or compound interest based on the scenario given. Andrew deposits 300 to an account that earns 2% interest each year. At the first year, Andrew has 306. So to do that, I'm going to go ahead and say, I'm going to put 300 and I'm going to multiply by 0.06 for 2%, 0.02. And that means that after the first year, you get $6. So it'd be 300 plus 6, which would give you 306. So that's so far it's simple interest. But let's look at the second year. So first year really doesn't, simple interest and compound interest is the same. Second year, Andrew earns 312. So I know that $306 plus another $6, which is off the simple interest, makes 312. Right? And then after third year, it's 18. So another 12. So this is going to be simple interest because you started with 300, and then 6% and 2% is going to be plus 6. So the first year, you're going to get plus 6. Second year, plus 6. Third year, plus 6. And they're all going to be 6. So total is $318 because 6 plus 6 plus 6, or 6 times 3 is 18. So this one I know is going to be simple interest. Okay. And it doesn't mean automatically the second one's going to be compound, but let's look. Okay, Maryland deposits $600 into an account that earns 1.5% interest each year. So we're going to times that by 0.015. Okay, so you start with $600. Okay, and then the first year, right? I'm going to add $9. Okay, now if I add another $9 the second year and I add another $9 the third year, then that means it would be simple. But let's see. So after the first year, 609. At the second year, 618.14. So I don't think that's going to be simple anymore, right? So, but let's see how that works. So if I add $9 the first year, right? First year, $9, right? Then I'll have 609. And if I multiply that by 0.015, the second year I'll get another $9 and 13 cents or 14 cents to it, right? So it's actually plus. So the second year I would add $9 and 13 cents or 14 cents, right? And that right there tells me that it's going to be compound interest because I'm adding a little bit more every year. Okay. And after the second year, she makes 627. So I'm going to say this one is going to be compound. Okay. And it's not a lot of work. It's just using the calculator to figure out how much you actually have. Right? You can also write this one as 600 times 1.015, and then to the power of, if I do power of 1, I'll get 609. If I do the power of 2 for the second year, I get 618 right here. If I do it to the third year, right, that's 627.40. So right here. Okay, so it all works out, and that's definitely compound interest. Okay, number 5. Write a function to represent each problem. So we're not actually solving it, we're just writing a function. So Perry deposits $175 into a simple interest account. So this is going to be, we're going to write it as P of T, or you can write it as A of T for a final amount. But I'm going to go ahead and do P of T because we've been working with P of T. 175. Interest rate for the account is 4%. Write a function. So this is going to be plus 175 times 4%, which looks like this, and times the time. Okay. Now, if you want, you can write it also like this. P of T equals 175 plus, and then you can figure out what 175 times 4% is. And that's how we were working with Nikos. And that gives you $7. So you can also write it as 175 plus 7 times T. And that also works. Okay. So you can write it either way, and that's fine. Okay, number 6. Julian deposits $500,000 We're 50,000, so we're gonna go P of T equals 5,000. Simple interest account, so that's gonna be 500. Sorry, 5,000. We got a zero here. Interest rate of 2.5, so that's gonna be multiplied by 2. Sorry, 2.5 is 0.025 times the time. Write function, okay? Or you can write this as, again, if you want to multiply the 5,000 and the 0.25, 0.025, you can write it as 125. So you can write it as P of T equals 5,000 plus 125. And again, that's all of this already. And all I have is the T. So I just have to write 125 T. Because remember, 5,000 times 0.025 is already on here on the calculator. Okay, number 7 for green. Shen deposits 300 into a compound interest account. Okay, so this one's compound interest now. So P of T equals 300. And compound interest is going to be 1 point, and then the interest rate is 1%. So it'd be 1 point. And remember, it's you can write it as 1 plus 0.01 to the T power. Okay, or if you want, you can write it as P of T equals 300 1.01 to the T power, and that is also okay. Okay. 8, Leah deposits 450 into compound interest account, so we'll go at P of T equals 450, 1 plus, and then the interest rate is 5.5, so it's going to be 0.055 into the T power. Okay. Or if you want, you can write this as P of T equals 450, and then parentheses 1.055 to the T power. Okay, no work needed on that. Okay, that's the first page. If you need to, you can pause or rewind anytime you want. Okay, Sherwin deposits 500 in simple interest account. Interest rate is 3.75. The function determine the balance after the game. Okay, so on these, they already give us what we want, which is the P of T. So they give us our equation. So all we have to do is just copy it down. So P of T, but then this time we want to know for 50 years. So P of 50 equals 500 plus 18.75 times the T, which is 50. So this is just plugging it into a calculator and working it out. So 500 plus 18.75 times it by 50. That's all you got to do. Okay, and you get a total of 1,437 and 50 cents. Okay, I'm gonna use orange. All right, so 75 years. So same thing again. P of, when I put 75 equals 500 plus 18.75, and then we're gonna multiply it by 500. Okay, and we're gonna put 500 in there. Okay, so we're gonna work it out on your calculator. 500 plus 18.75 to the 500 years. Oh, sorry, not 500, 75 years. I don't know what I'm doing. There we go. Okay, so I messed up on that a little bit. Okay, so the correct answer should be 19, so 1,000, $1,906.25. And these were not 500s, by the way. These were 75s. Okay. Okay. Hector deposits $400 into a simple interest account. So let me go P of T. Oh, actually, they have it right here. See, I keep wanting to actually write it down, but P of T, and basically they want to know when does it double, right? So P of T, so the original amount is 400. So here, I'll write this one down. P of T equals 400 plus 21T, right? And we want it to double, so instead of P of T, we're going to write down 800. Okay. And to do that, we're going to go ahead and subtract 400. So 800 minus 400. You can do that in your calculator or in your head. Just showing you guys this is actually 400 equals 21T. Okay, I took away 400 already. So that cancels. Okay, and then I'm going to go ahead and divide this by 21. That's going to cancel. And that's going to give me my T. So T equals what, right? So that'll be 400 divided by 21. That gives me 19.04. So we'll say about, so we'll say approximately 19 years. Okay. Triple the original amount. So 400 triple times 3 is going to be 1200. So I'm just going to go ahead and cut to the chase. I'm going to start with 1200 equals, because that's triple 400 plus 21 times T. So again, I'm going to do the same thing. I'm going to go ahead and subtract 400. Okay, so 1200 minus 400 is going to be 800 equals 21 times T. Divided by 21, which will cancel the 21s, and we'll be left with T, and we'll say this is approximately equal to, we'll go 800 divided by 21. That get us 38.09, so we'll say approximately 38 years. Okay, last two. Cisco deposits 500 to a compound interest account. Interest rate for that. So again, we want to do the work, but you know what? It's okay. They already gave us the compound interest problem right here, and we just want to do 50 years. So we'll do P of T, which is actually 50 years, equals 500 times 1.03. I like the parentheses because it's much less confusing, and then 50 power. Okay, so we're just going to say, what does that equal to? So 500 parentheses 1.03 to the power of 50. Okay, that gets us 21,000. Oops, sorry, not 21,000. $2,191.95. Okay, and the last one we got P, and we're going to do the 65 years. That's going to equal 500 1.03 to the power of 65. Okay, remember how I showed some of you guys in class? Just use this and copy it down again and change that from 50 to 65. Okay, or you can type it over again and you will get a final answer of 3,414 and 99 cents. Okay, all right. I hate to play and leave, but I gotta